Chris,
good day, everyone. It's Alan Schimmel, DevOps.com. Thank you for joining and welcome to another DevOps.com webinar. We have a great webinar lined up for today. It's actually a real case study, which is always good to hear. Our webinar is sponsored by our friends at InfluxDB, and many thanks to them. And we're going to get started here in just a moment. For those not familiar, we use the GoToWebinar control panel for our webinars here at DevOps.com. And today, as usual, we'll be using it. We have set aside time for questions from the audience. We'd really appreciate it if you would be able to type your questions into the questions section of the webinar control panel. You all should see that. For most of you, the control panel's in your top right corner. And there's a section marked questions. If you click on the arrow so it's downward facing, you'll see it expands. And we're going to ask that you type your questions in there as you think of them. Don't wait till the end of the webinar to ask your questions. You may forget them. There may be a rush of people asking questions, so we won't get to yours. If you type it in as they pop into your head, they're saved in there. We have them in queue, and we'll do our best to get them. If you're having a technical issue, though, don't go to the question section, because sometimes those aren't looked at until, the questions part of our webinar. If you have a technical issue, please go to the chat window, which is on the bottom. We do have engineers standing by that would address any technical issues you may have. So please use chat. Maybe your slides aren't progressing or the audio is bad. Use your chat window. We'll do our best to try to help you. With that being said, though, let us now return and get started with our webinar. As I mentioned, today's webinar is sponsored by InfluxDB, and it's a case study on how CJC built a performant big data visualization platform to be used by their capital market customers for ITOA with InfluxDB. Well, that's certainly a mouthful, but we're going to learn more about that shortly. Our presenter today is Steve Moreton. He's the Senior Technical Director of CJC. We'll hear more about him in a second. But Steve, are you there?
I am indeed. Can
Fantastic.
You hear me
okay, Steve, if you're ready to take it away, I know you chimed in right at the beginning. Any problem or anything?
Nope, all good from my side. I just want to say thank you very much for giving me the opportunity to present the case study of MosiacOA, especially to DevOps and to InfluxDB. So very much appreciate the opportunity. Thank you.
Our pleasure, Steve. Okay, it's all yours, my friend. Take it away.
Great stuff. So I've just been warmly introduced to Steve Moreton from CJC. I assume a lot of people won't know who CJC are. Just to give you a bit of an insight into the company, CJC are a capital markets focused managed service provider. So the capital markets, for those who don't know, there's obviously the investment banks, there's a lot of exchanges, and there's market data and lots of other forms of data which are distributed around the world from places like the New York Stock Exchange, the London Stock Exchange, Hong Kong Stock Exchange. And that data is sent to investment banks in real time, and it's very low latency, very fast paced, and everybody in the capital markets community needs to receive that data when it's sent in as low a latency as possible. And our company are experts in the distribution technologies which do that. The data is sent from exchanges directly to clients, or it's sent from exchanges to vendors such as Bloomberg or Thomson Reuters. And then the technologies which distribute this out locally to the client sites, potentially going to one user or 1,000 users at the same time at a client site, that's where we have always come into play. And we provide managed services around these technologies. So one of our biggest customers is actually Thomson Reuters themselves, and we're supporting 20 data centers for them in 22 geographical locations. So there's quite a few thousand servers there. And when you're a managed service provider, One thing that everybody wants to see is visualizations of how their infrastructure is doing. So we have some very, very advanced monitoring systems on there, so we can see problems as they happen. But the historical problem is that you want to be able to project or do capacity management on these systems. And it's never been something that we've been able to do particularly very well historically. And what I'm going to do is I'm just going to show you a couple of slides here. So this is an example of the kind of reporting we're doing about 2010 to about 2014 we were doing this. And you've got some server capacity reports. So we're taking information like CPU, how many users are connected, how much RAM is being used. But you can see there we've got October 2012 to January 2013. And you've actually only got a few points of data there. And then you've got like a very basic, we project that this is going to happen there. But a CPU does a huge amount of data, and we're taking a vast amount of granularity in there. If you actually look at some of the more granular data, again, we're only really taking one update per hour. And again, is that the peak data? Is it the min or the max? So although these were fine and sufficient, it really wasn't giving us a very, very accurate view of what clients wanted to see. And clients have not just one type of infrastructure, they have multiple types of infrastructure on site. So you might not know some of these names, but obviously Bloomberg has infrastructure on client sites, Thomson Reuters. And then Exergy is just one example. As I said, you've got exchanges which are trying to send data, which is being distributed across clients' infrastructure. And we've got Solace here, which is a middleware messaging appliance, which is becoming quite popular in the capital markets. And as time's going on, these are very critical systems. It becomes so important that you know where the problems are developing, where the capacity is. And this is a concept called ITOA, IT Operations Analytics. And basically, we had one of our clients come to us in around 2014 saying, look, they wanted to have a ITOA solution. And if I just go through what they were, some of the key challenges is here, is that they were, just try and get that up. So basically, when you've got all this infrastructure, let's say you've got about 50 servers in one location, you're taking and you're monitoring all their CPU information, Linux information, memory, but then you've got these application specific pieces of information as well. And what was happening is they were only logging the data to do visualizations. When you've got 50 servers, there was about 256,000 things they could be looking at and could be logging, but they were only actually logging 5,000 of these metrics. And they were very much human decided metrics. They were things like, okay, let's get the CPU information, how many users are logging in, and it was just a handful of data. And because the monitoring system was giving the databases quite a high throughput of data, even on that small handful, the data was getting very big very quickly. And so they could only keep the data for a short amount of time. So they were keeping the data generally for about 3 or so weeks, maybe a month. And so basically the information was then purged or deleted. Very little was kept for, let's say there was a market swing event where there was some volatility in the market, you would lose that data. So you couldn't really see what was going on in the past and where your true capacity was. Also, the database types were not really fit for purpose, I'll put it. Time series databases actually are excellent for doing real-time queries. So the database was a problem, and not only that, the clients had a problem which was internal charging. Many capital markets participants are in very, very prestigious kind of high value locations. So just having a server in your own computer room was like, the TCO was $20,000 a year just to have a server sitting there being supported. And then obviously when you have the database costs and the internal charging of databases, that would grow. So sometimes it was just too cost prohibitive to actually even store this data. And this is a solution that RBC came to us with. And we had a look at what we were doing, and we just realized that we need to take a fresh look at this. So we in effect scrapped this and we created it from anew. So I don't like a death by PowerPoint approach. I'd rather a bit of a show and tell approach. So what we've got here is MosiacOA. So we have our own cloud at CJC. It's a hybrid cloud, so we're connected into AWS, Azure, Google, and so on. And but we have our own technology. So there's Equinix data centers. So we're in 3 Equinix data centers in London. And what the client does is they have a monitoring system which monitors their entire infrastructure globally, and they stream the data of everything happening on those servers, and it's all streamed real time over a cross connect. The cross connect is from there. We're in the same data center, so they stream the information via messaging system into our environment via a cross connect, and then we can see their whole global estate. Now, this client is RBC. They're the initial early adopter of this new site. They're very, very proud of this system. They're very, very happy for us to show off this system. I go to events all around the world, and sometimes the client's there and they're pushing people in front of the screen to see it. And what we have here, we have a web GUI which interrogates the Influx database. And what we do is we can then interrogate this database. So as you can see, I'm looking at a term called gateway here, which is the location. So you can see we've got London, New York, Toronto, Hong Kong, Sydney, and Tokyo, which is available. If I just close this off, it then interrogates the data in a different way, and I can see absolutely every one of their appliances now, all their servers from all across the world. And this is just basically interrogating that Influx time series database. And I can sort of chop and change this around, so I can, instead of looking at the managed entities, the servers, I can look at the specific monitoring information as well. And I've got a lovely way of being able to drill down. So I mentioned some of those names there, like Bloomberg. So I can just do a search. Obviously that was at the top, but if I type in the Thomson Reuters term, we've got a server called an ADS. So I can see all their ADS servers. And I've just mentioned Solace, so I could just type in Solace and it'll bring up the appliances. But what I could do is actually type in something specific to the Solace appliance, which is message VPN. And then what that'll do is show me all of their Solace appliances all across the world, which is a very nice way of interrogating the data. But obviously what you want to do is be able to see some interesting information. So I'll just try and so if I just get some key pieces of information there, I can do a drag and drop of, let's say, the Solace hardware into what we call the inspector view. And then what I can do is investigate everything going on in this appliance. So if I just open what I call a preset here, and this is a production environment, this isn't a mock-up, this isn't canned data or anything. And all I'm going to do is I'm going to look for something like CPU. Hopefully I'll find some CPU information, and then I drag and drop this in. And of course it's a demo, so it doesn't quite work. Let me just here's what I made earlier. Drag and drop this in now. I'll be able to see the CPU information on that appliance. But what was interesting is that's only showed me a partial amount of data. Just bring that in. I can look at 1 day's worth of information here. But potentially I could say, look, I want to look at every bit of information which has ever occurred since time began when I first started getting that data in. So if I just look at CPU information from one Solace appliance, you can see I've got nearly 1 million metrics from just one device and one CPU piece of information. So I've got approximately in this environment about 250 servers in this environment. So what's actually happening is streaming from this client, they've got 250 servers being streamed into the database. That equates to 100,000 updates of new information per minute, and that is all the data which is coming in from the monitoring system through the messaging that we get. But we do have other clients as well. So we've got another client here, a totally separate client, and what's actually happening is they have 1 million metric updates coming into the databases every minute. So it's just showing the power of Influx, really, is that it can handle these very, very large amounts of both updates coming in and disk writes as well. So very easy there. I've just shown you a couple of things, but obviously you might want to see a little bit more than that. So you can actually just say, look, I just want to look at all these particular ones, and I can look at CPUs here. Just get rid of this, and then I say, look, show me all the CPU information from all those devices I've just selected, and then it can go in. And Influx is fantastic. So what we've been able to set in the front end, so I'm seeing all the information here. When we were designing this from scratch, we wanted a bit of a Google Earth approach to looking at the data. So what I mean by that is, if you look at the whole of the world from Google Earth, you'll see a very accurate representation of what the Earth looks like. And this is the same here. I've got all the data I've got. So the first amount of data I've got access to is on the 14th of April. I've got a year's worth of data here. I can then select that, and then I could zoom into just this area here. And then, same way as if you were zooming into your house, it can then give me a much more accurate view of that data. It will go into the more granular versions of the data. And we have a similar approach. Let me just bring up another site here. It's here. So just bring up the control box. So again, I can get all my all-time information. This is a fairly new client. So their data came in from this period. And I can say, look, just zoom into that particular day. Here, and then if I just do a refresh, it'll pull in the more granular version of that. Again, this is a feature we've manipulated of Influx, and what we have is detail and data retention policies, which is one of the key features of Influx we found. So this is huge amounts of information. I've got one client, again, they're giving me 1 million metric updates every minute. So since they've been on since the 15th of February, that's something like 13 billion metrics, which are now in my database. And I keep everything as granular as possible. Each one of those updates is still in my database. But potentially over time, do I need to keep that granularity? So I have set various policies in place here. So one policy I've got is that I keep all the data for 60 days. Every single one of those million updates per minute are stored. But then after 60 days, I then change that from the most granular version of the data to 1 update per minute. Now that update composes of the min, the mean, and the max. And I keep that for a further 30 days. So it's 90 days of less granular data. Then after 90 days, it moves to an hour. And then once we get to 180 days, we only keep the daily information. And that's given us some really nice little features here. So if I just go back to one of the other environments here, I'm just going to bring in a bit of a nice preset to give you an example of how that looks. And so what I'm going to do is this is 178 days worth of data. What I'm actually going to do is say, look, show me 365 days worth of data. And what you can see here is that the data is quite spiky. This is the hourly version of the data. When I click on apply, brings the data in. It's still got the same shape, but now it's just showing us the hourly information. And this is quite handy now, is that I can keep on going back in time. And this is something which should be missed. So you can quite clearly see I could go back, let's say 3 weeks here, And that's all the old information that I'd be able to keep. I'd have to be deleting all that data, which is considered here. And I wouldn't see things like this here. This is a market swing event. This was we see a lot of these in the capital markets. It's sometimes something that Donald Trump's doing, and we can keep that information forever now. So this is quite a handy thing, and this is a real world thing that our product has been able to help the client with. So what we can do is I can add a trend line to that data, and I can actually do a projection. So I could say, let me see where I am in December the 31st, and click on apply. And then I've got a projection here saying that I'm going to be at about 5.6. But if I just change this now, and what I'm going to do is I'm going to, in effect, replay how the data looked not so long ago. So I'm going to change it to the 2nd, just before Valentine's Day, and click OK. And what was actually happening here is that this is the data, and what they saw is that they were projecting to be at 7.79 million, what they define as subscriptions. So the data you're seeing on screen here is there's a middleware messaging system called Solace, and this is all their market data and various other pieces of data which is going across their backbone. And in effect, they saw that, if I just say it was about October the 1st, 2018, they were going to hit around 7 million. That would have meant that it would have crashed. There was no two ways about it. They would have crashed at that point. So what I can do is I'll just keep this up here. I'll just bring up the preset again. And I will then just do the same trend line now and the same end date. And what I'll just do is change it so it's got the same amount of days in, which was 365. And then you can actually see how they've actually added tuning at this stage. It's a nice little feature we've got. So when I'm moving my mouse and cursor, you can see the line correlating. So you can see the point that they either did tuning or moved data onto other parts of the backbone or added new devices in, and then brought that data right down because they've changed it. And this is the thing about data. One of the features we found with clients is that you've got different teams who have different requirements. Some teams in an environment might need to see that 365 days, but other people may only want to see the last 10 minutes, for instance, and they might only want to know what's going to happen potentially tomorrow. So what they can do is click on apply, and then they can see what things are going to happen in the next few minutes. They can change it from the last 10 minutes to the last 5 days and so on. And this is how data changes what's going to happen in future. And this is one of the key features. And you've only been able to get that because Influx has got very, very good data retention policies. So the specification that we use is, it's not, we've got our own private clouds, and I think we've got 3 servers which are used as a production environment, which have got 32 gigabytes of RAM, 4 CPUs, but the data is only 500 gigabytes of data, and it doesn't grow. So once you're using the data retention policies, once it gets to that key moment of where it gets to 180 days, the only information you're keeping then is the daily information. So in essence, you've got 250 servers giving 3 new updates, every day. So it doesn't really make the data grow. The only thing which makes the data grow is when the clients add new servers. And this has been a very, very successful POC. They've moved into production about a year ago. They've recently expanded, so they've got more sites coming into it. And they're soon moving it into more areas. So beyond just their capital markets infrastructure. They're going to be moving it on. They've got 250 servers at the moment, It's potentially 2,000 to 4,000 servers they're going to be putting this onto, because they need to do accurate capacity management. They have seen some very, very unique cost savings and being able to actually isolate where the servers with spare capacity or servers which are running out of capacity. There's a lot of lovely key features here. It's very customizable front end, but a lot of the features are based specifically on InfluxDB. So we've got really good ways of bringing in the data. Again, we've got some very, very visualized environments here. I'll just open up a new one. But we don't just look at the, sometimes you don't want to look at the visual data. Sometimes you want to look at the text-based information. So we've got some information here for another client that what they wanted. They just want to see the uptimes from the servers. So we give them what the uptimes are. So it's very, very, very interactive. It's great. We can show any type of data the client wants to see. We've got multiple ways of interrogating the data, and it's really just instructing Influx on what to do. What we do as well is we eat our own dog food, so we actually utilize our capacity management tool to do capacity management of the capacity management tool. So we have our own private cloud at the moment, but obviously public cloud providers like Google, AWS, you know, they're very interested. The costs and the economies of scale are very desirable to ourselves and the clients. So we've got the ability to investigate our own environment. So this isn't a client environment now, this is my environment. This is all the things I monitor in my environment. And I can type in, I've already got it up on screen. So I can expand that out. I can see all the specifics of what's happening, so I can get my my write rates. Let me just bring this up. So what I can do is drag and drop this in, and I can look at how my write rates are going. I'm just going to switch the view of it a little bit. So I'm going to add it to a stacking group. And then what I can do is I can see how my write rates are going. So there's been some interesting information discovered actually. So when I actually look at the client which is doing 1 million metric updates per minute, actually you can barely see their write rates, because what we've done is when we've looked at the data, the monitoring system is kicking out a huge amount of data, but that data is the same. So there could be 32 updates a second, all at 10. So that doesn't really affect the write rates here. But the clients which are doing 100,000 updates per minute, all those updates are different. So that increases the write rates. And again, it's so good that I can look at this and I can say, look, I don't want to just see, you know, a particular version time. I can go to the database and I can say, now show me the all-time information. So I can actually see how my system's in effect grown and how more and more clients have been coming onto the system. I can look at the data in different ways. So I can see where my very, very highest write rates were on the system. And this is good because there may be a client who comes along in the capital markets. Regulation is very key. So we have clients who are upcoming at Singapore, and they can't access our private cloud because they can't have the data. Their data can't leave Singapore. So we have to use the public cloud in that capacity. So write rates then very interesting. This is where I've looked at things like AWS and the Influx cloud. So we know that the write rates, and we've got good projections of what the client's going to be doing. So we can actually be very confident that our capacity management system will work in things like Google or AWS. And then we can just orchestrate the system and give the client access. We can look at things like the bandwidth of what our own bandwidth is and things like that. So we've got other views where we're saying, look, we can see that we've got like a site-to-site VPN where the client's sending the data, and they're only using, 10 megabits of data per second. Sometimes there's a spike which we can handle. Other clients who are doing very high bandwidth traffic, and so we might need a better connection and so on. So it's quite a good system, and again, it's all been based off Influx. What I'll do is I'll just go into again how the data comes in. So this is a standard environment. So I've just shown you our environment there, where we do capacity management of the capacity management system. Then we have a QA area. Because the data sets are so large, it would, if we just put a new, what we call a gateway, a new monitoring system on into it, it would crash the entire system. We need to have a separate area to onboard. So we have a QA area, and then we have a production area. And then generally at the client site, they have their technology, which could be the monitoring system, it could be the messaging systems, the Thomson Reuters or Bloomberg systems. And then they have the messaging platform to send the data securely over to us, which we subscribe to. So the final thing I really want to sort of go into is the future. And what I'm going to do is I'm going to show you a quick screen here. So machine learning. If you have got the data, I go back to something which I saw on a TV show once. NASA's got a formula written on a whiteboard somewhere, which has got the end of the world. And it's got quite a lot of gaps in it because they know the formula, they just don't have the data yet. And this is a key thing, is that you can't really predict an environment if you haven't got the data to predict what's happening. So this is where now we've got the data, we use Influx to, every 5 hours, we create a new database from the original database. And what that means is, I'll just try and bring up something here. It means that what we can start doing is we're looking for specific pieces of information which stand out. So we can start looking for correlations. So because there's so much data, there's a lot of noise there. And what these things do is that by creating a new database, and we're looking for CPUs which go over a certain level, and these will just stand out all on one line, and we can just see this in the new database. And then we can start seeing where potentially patterns are emerging. So these are things that we're starting to build now. And so we use the data we've got, and we've got all this data, all this long-term data. We can start finding out where projections are. We've got a really good way of being able to look at the error messages which are coming in now. So we can look at all the servers, and we can work out where potentially the problems are. So we can say we know potentially what servers are causing the most problems, but then we can actually get down and say, look, it's not the server, it's this particular specific problem. And then we can correlate that with other things going on at the system at the same time. So we can do analysis of the events which are going on, but then we can start doing some interesting things like comparative analysis. Let me just bring up another window there. So what we have here, it might not be amazingly interesting information, but this is where we've been able to, clients come to us and said, hey, we'd like to see something interesting. So potentially they want to know where they are in a day. So you could have something like a CPU, which is at 60%. Is that good or bad? Who's to know? It could be 80%, and that could be completely fine. It's how it equates to previous days. So what we have is this green area here is generally how big it's got in the past. We can see where it's gone, and then we can see where we are today. The purple is where we are today, and this dotted green line is where we're projecting it's going to go. So we can say, hey, this could be, although it's quite small, this information is, that could very easily be 60%. The user knows that that's not a problem. That is absolutely fine. That's completely in its server's abilities, and it's not going to be any cause or consequence. What it's probably be is if it's going beyond what it's ever done before. So, and now what the thing we're doing is using that, creating a new database to do machine learning. That means we can get all the infrastructure, in essence, put onto one line. So we can get all the infrastructure, and we can actually tell somebody very, very simply, is their infrastructure causing problems? We get this information. Let me just bring up the screen here. And so we can start defining now which servers are hot and which servers are cold. We can combine all the information, as I said, so we can get all the CPUs combined and see what all the CPUs are doing in relation to what they've done before. Again, we've got the comparative analysis, we can have an event analysis, so we can start really understanding the infrastructure very quickly and very simply. I think that's I could talk all day about this, but I thought what would be good is maybe it might be a good time to move over to Q&A, or if there's any areas people want me to go over again.
Excuse me, I'm sorry. Hi, Steve, it's Alan. So we've got a few questions here from the audience, and if you're done presenting, we can jump into them, okay?
Yeah.
Okay. So our first question is from Ben, and he wants to know, did you modify source code of InfluxDB, or did you just use InfluxDB out of the box?
We had this question, and it's just straight out the box, InfluxDB.
How big is the cluster servicing this dashboard? What does the architecture look like?
Okay, just give me a second. As I said, I've got my environment here. So let me just have a look at this. I've just got to change something quickly. So what we define as this is a mod, and so the monitoring system, we get collectors. So the data source, this is just visualizing data that's been created from third-party systems. So there's a monitoring system we use, which is quite common in the capital markets, called ITOA, and a lot of monitoring systems may only do an update every 15 seconds or every minute, but in the capital markets, there's a lot of things which can go wrong in a second. So this is designed to do quite a lot, potentially 32, however fast you want an update, it'll provide the updates. And what we do is we scale that based on key information. So how many updates per second is going to be? How many, so it's a data view, how many data views are there? So a data view would be CPU information and everything which comes under a CPU. I'll just try and show you here. So, so in essence, this is a server, but these things here are data views. So we count how many data views are there, and underneath them, we have something called the values here, how many values come under a data view, and they're called XPaths. So we have a scaling model of how big the server needs to be. And again, what I was trying to show you here is the 250 servers, the client has what we define as 6 mods, which is 3 servers. And each mod comes with 500 gigabytes of data. And that is where, so each server has 2 InfluxDB databases running, which are in sync. So this particular client has 6 databases running, all integrated, and in total it is it's about 8 terabytes of data in total, which we're not sure they're using, but that doesn't grow. Again, this goes back to that conversation I was having about the data and detail retention policies. So if you're doing ITOA, it's an argument here about, in 365 days, do you need all the information which has happened today? Because you've got 60 days to review that data. If there's been an incident, you can replay that data, you can review that data, and then you've got 60 days to go, yeah, I've done it, but I still need to then keep the shape. And that's why we move into minute and then hourly. So the client's got a bit of time to then sort of go, if there's something they've missed, they can still probably see a bit of data there. But then once it's got to a year, it moves into the daily updates. So you're not going to get much granularity with, in essence, one update per day, but you still keep the shape there. And what that means is that cluster, that sizing doesn't really grow. It grows very slowly. The only thing which increases it is, when the client adds new servers. Now, what I would say about the sizing is that our client base in the capital markets has a lot of specialist infrastructure. Now, I'll go back to this. It's very, very, there's a lot of logging. There's a lot of things which are updating. There's quite a lot of, like I said, the data views. So it's not just CPU and the sort of commoditized baseline statistics. It is very specialist application level data, which takes up quite a lot of the capacity. But as clients have moved into more, so if I just go back to this here. So this here is about 6 mods at that line there. They're currently using, just go to the max. They're right now at best. In the last March 12th, they were using 5.1 mods. This is their current capacity here. We do allow them to go over now and again. Because it's so specialist, 250 servers on 6 mods. But if you're looking at baseline statistics, like which is CPU, memory, hard disk, network statistics, we believe that one mod can do 100 servers of baseline statistics. So in essence, 4,000 servers would be 40 mods, and so on. So hopefully that's answered that question. Is there any other queries at all?
Yes, we do have a few more, Steve. Can you please share which metrics were important to be measured for ITOA in your scenario?
Well, there is the baseline statistics. I'll just, I shouldn't do it. Let me just bring up this one. So this is a particular client, and you can see that we've got here, this is Citigroup. I always get told off if I show this, but we're all under NDA, right?
Yeah, sure.
So we've got quite a few different things here, which are, so obviously you've got things like CPU data, and CPU is very important. You need this to correlate what's going on. So you can see here that we had a spike, and you can actually see that actually, let me just get a presentation point here. So you can see here we had a spike there, and I think it was at that point there, you could actually see that was there. So these update rates, an update rate is, you have a market data instrument, which is like, just trying to think, like Google has a market data instrument, like goog.l, and that can update, that instrument from Google can update 1,000 times in a second. And then some clients are pulling in thousands and thousands of instruments from all different companies over and over and over again, all of them potentially doing thousands of updates every second. So what we're doing is update rates has an effect on CPU, and then obviously CPU can have an effect on something else. So we can measure anything we want in the database. Again, there's a correlation between the baseline statistics, things like networking and RAM. Like we've got something here. This is a classic example. There's one network card here which is specifically important. It's the Ethernet 2 statistics, and what you can see here is that it's pulled in. You can actually see the days, the weekends, and so So this is something that all servers have. All servers have an Ethernet card. Sometimes they're tuned for a specific thing or a specific function. In this case, this one is. But then this one is actually doing update rates. So what we can do here is actually we see, look, there was actually a spike in the Ethernet here. So there's something called a multicast storm, which was caused from another data center. But then we can actually see how that affected the server, and it didn't affect it at all, in essence. And this is brought up quite an interesting conversation, actually. Is if I get a trend line here, just put a trend line in, and I'll just do a quick projection again of where my updates are going. You can actually see here that my projection is going upwards, but the problem is I've got huge gaps in this data. I've got my outliers of the fact that there's no market activity. You know, at a weekend, there's very little markets open. In the evening, the markets are closed. So what we're doing at the moment is we're actually looking at a way to instruct Influx to ignore these non-market periods, because that affects our trend lining. And it's something that nobody's ever actually thought about before, because nobody's had that much data to play with. Nobody's had that ability to see a year's worth of data and then actually realize, oh crikey, we've got this huge problem here, which is the non-market hours. So what we're going to do is we're going to have it where we're going to remove these gaps, and then we're going to, you know, find out some sort of interesting information. And being able to shrink the data like that is very interesting, because sometimes when you're looking at it, so if you just take that off and just bring it back to today. Like that, it's very hard to actually see here if it's growing at all, because you're kind of like right in it. But when you actually see it over time, and again, I'll just bring it back to December the 31st. Click OK. You can actually see potentially, yeah, there is some growth going on. And then when you actually see this by the end of the year, you can actually say, yeah, my data is growing. And then you can start saying, look, this is where my update rates are going to be. This is where this is the effect. And you can actually see very clearly how an application is affecting an Ethernet card. But then you can actually say, look, there was a spike there. You can actually then look on the other data center and actually get the root cause of what caused that and what you can do. And this is where we're building heat maps. So we can actually, when these things start to happen, we can actually predict them happening. Hopefully that answered that question. We've got, I've just got another thing I can show you. Again, this was something which, again, it's application specific. This is something called a snapshot. And this particular client does quite a lot of snapshots. This is where they take almost a photograph of all the market data in one go. And nobody's ever been looking at this. Nobody's actually even thought about, is this actually causing impact on the system? And what we've been able to do is say, look, you know, look how it's grown over this period here. And they went from doing 434 million updates, snapshots, to in essence 540. So they grew by 100 million snapshots in a short period of time. What this led us to do is actually go, let's have a look at all the clients, because this is a huge data center. It's not got one client on, it's got, you know, it's got hundreds of clients on, and that affects their massive monster backbone. So we can then say, look, how is snapshots affecting the backbone? These are questions we've never even had before. Nobody's ever intellectualized them or thought, because they're now looking at the data in a different way. Before, they were looking at the data as it happened. They were seeing like CPU, and they were, you know, finger in the air kind of, we should be looking at this and we should be looking at that. Now, because you can see all the data, it's something they call human machine learning. And this is a lot of engineers who are supporting systems have theories they've never been able to prove before. So just having it so you can store the data and visualize it actually quite affordably gives great power now to the, you know, the support teams and other parts of the business as well.
Great. All right, Steve, next one from Rob. Is this data coming from more than one source? If so, is the data displayed being transformed prior to being written into InfluxDB?
What we've got is we have multiple data sources which come in. So yeah, we've got quite a lot of data coming from monitoring systems, but all of these platforms actually have, we just call them an exhaust. So they don't really give you they don't really tell you how you store the data. That's completely up to you, but they will give you an exhaust to be able to store it. So what we do is, to get the data into Influx, we write what we call a collector. So it could be there's an existing database. That database could be Sybase, it could be SQL, but all our preferences now is to have a collector which takes that data and puts it into an Influx format in the time series database, because it's kind of completely in tune with our front end now. But generally, we've got CSV files as well. They're very, very easy to import. But yeah, we write a collector which takes the information from the client's information, or the exhaust, and then stores it into Influx. So when it's a known collector and we've already written it, we can onboard a client now in 24 hours. In terms of manipulating the data, yes, sometimes we have to. So I can't think of an example here, but sometimes in some data, the number just increments. So it starts off as 1, and then the next day it's 2, and the next day it's 3, or sometimes in a day it can move up by 50 and things like that. So all you'll see in the front end is like a ski slope of the data going up. And that's not actually telling you anything. So what we've had to do is sort of tell Influx, and we get our dev team to kind of say, Luke, just kind of add a time to the increases as well, and so on. So we can actually start seeing some actual shape as when things are happening. And as I said, we've got different ways of looking at the data. Like this is like, yeah, I can sort of say, Luke, give me, drag and drop the average CPU information, but then I can say, Luke, drag and drop it, so show me the peaks here in sort of like a tabular format. So when I click OK, you'll notice that that's got a data source which is metric DB values. And then when I go into this one, it's metric DB aggregated metric max. So each one of the windows in many ways is interrogating the data in a different way. And the logic of this is, so yeah, potentially through the same front end, we could have multiple different databases we're connected to, not necessarily Influx. Again, we've got some clients who import CSV files into the front end and so on.
Okay. Steve, we've got a few more questions and we're running low on time, so I'm going to ask if we can move along. What output does the machine learning processing generate? What tools are you using for that, Steve?
Well, as I said, what we're doing is we've got the data and all the data you've seen there, and then what happens is a developer set it so he's designed a threshold of where he wants to see. Let's say it's a CPU, and what he's defined is he calls it KIMP, a correlated input matrix process, and then he's got a pattern matching engine. So what he's doing is he's designed, and he believes he's got his own algorithm that he came out of university with, and so he's getting CPU information and so on. And he said, this is interesting, this will help me find correlations. And then the idea is that if he can see the correlations here, like, you can see like we've got here, there's a spike, and there's a spike there. He can then sort of go, like, look, there's something going on here. Every time this happens, this is causing some effect. So we're still building it. So what we've done is we've actually partnered with like a sort of data science company to be able to help us find these patterns. So this is something that we're still building in process. But the important thing is to have the data for long periods of time and keeping the shape of the data. So again, that 60-day period where you've got the full granularity, that's kind of like the key period where you can get all those spikes out. You're not going to really do much machine learning when the data is moving into minute or hourly or daily information. So, but again, keeping that data for 60 days, huge amounts of data, we've never been able to do before at an affordable cost. And that's where kind of Influx came in. And then the ability to sort of go and interrogate the data and create a new database. That's how we're doing it. So it is a bit of a work in progress still, but it is the ability to use the correlated inputs matrix processes. It's already having some benefits where we can start doing, where the biggest spikes have been and where we are today, the ability to do event analysis in a deeper way. So we can say, look, because these infrastructures are so big and because they're so noisy, sometimes we just want to look at, we've seen there's been an issue, we want to replay that issue. Nobody's ever been able to do that before. So you can say, look, I had an issue which was, on between this day and this day. You can click on go, and then what you can do is you can actually review all those things and start actually seeing what went wrong at that moment, and then review what was going on at the CPU. Again, those are things where you can help identify correlation, and that's where you can start instructing either the Mosaic, the front end, or even the monitoring system, the separate system, to say, look, this is what you need to be doing now because this event is happening behind the scenes. The ability to replay it is very important, and so on. Hopefully that's answered your question. If I would say I am the product manager of this, and I'm a bit of a jack of all trades, so I have to get involved in the front end, the infrastructure, the marketing, and everything. So if there's any questions you want to specifically ask, feel free to follow up, and I'll sit down and speak to the development team. And we're big advocates of this. I believe that big data visualization is a commodity that everybody should have, and it should be affordable. So it's something I'm very passionate about, and I'm happy to share as much information as I can.
So Steve, one last question here. Is this a custom UI or is it built on top of Chronograph?
No, it's not. So what we did was, I sort of showed you, we had this very basic version. It was very static, it was non-interactive, and so on. A colleague who we've worked with for many years, he actually was the CTO of the monitoring system, and the monitoring system, ITOA, got bought by another company. He got bought out, and the one thing the monitoring system wasn't actually doing was visualizations, and it was a thing that nobody was really interested in. He was quite ahead of his time, so he actually built the front end to do what the monitoring system never could do. And he was actually investigating some other areas. He was looking at trade data, not actually IT information. So he actually developed this from about 2012, and I used to work in Hong Kong, and I bumped into him at a drinks, and he said he's working on something, and it was just the timing was right. He showed his system, and it looked pretty much as it looks today. A lot of work's gone into the front end, a lot of development, but not as much as has gone into things like the infrastructure, the database, the way we query the data, the policies and things like that. But he's developed some really key features, like a lot of clients want to have the ability to have a URL link that they could send, and then they can just log in. Somebody who receives that link can then see the things they want to see. And there's generally always access, so people want to just take this one screen here and then integrate it into a third-party system. So the front end it's not like a Grafana or anything else. It's something internal which we have co-designed and built based off an initial development.
Excellent. Well, Steve, we're at the top of the hour here. I don't think we're going to have time for another question. I do apologize. There was just one or two more. But you know what? This was an amazing insight, man. Thanks for giving us a peek behind the curtains here. It was enlightening and interesting. So thank you very much. Thank you to Influx Data for sponsoring today's event, and thank you all for listening in. Until next time, and we hope to see you soon at another DevOps.com webinar. This is Alan Schimmel for DevOps.com. Have a great day, everyone. Bye-bye.